So on this one here, we're talking about C. We're supposed to explain why Katrina's diagram in part B will not give her the correct length for 4 groups of 2.5 plus 1. So again, why this doesn't give her the correct length. And we already know this based on what we did up above, that she was thinking that she had 4 groups of 2.5 plus 1 instead of 4 groups of 2.5 and then 1. So right here, we're going to go back over here. And so she's going to be off. Now, the question is that I asked in class is hers shorter or longer than what we drew in A? So her routines should be longer because we have the 4 groups of 1 instead of just 1 group of 1. So Katrina's routine will be longer than A. So how much longer will it be? So instead of being 11 feet long, hers is 14 feet long, which is 3 feet more. Okay. So Delta in turn says, Cecil changed Katrina's set of instructions so that the length of the 1 foot came first, shown in the diagram right here. So right here, this guy. Write an expression to represent this new diagram. How far does Cecil move here? Does this give the same length as 4 groups of 2.5 plus 1? So the first thing that we need to do is to write an expression to represent this. So what is Cecil's first move? Then what happens? So his first move is that he moves 1 foot. And we can see that right here. Then what happens? So we can do one of 2 things. We can add 2.5 plus 2.5 plus 2.5 plus 2.5 after our 1. Or we can maybe use multiplication as repeated addition to help us to make it shorter, so we don't have to write so much. And so if we were to do that, we have how many groups? So we have 4 groups of 2.5. So this is our verb. It was told us to write. So the next part of our answer needs to be this question mark. How far does Cecil move here? So we have 1 plus 2.5 is 3.5. And then we continue on. And we end up with 11 feet. And then our third part, does this give the same length as 4 groups of 2.5 plus 1, or what we had up here? And the answer to that is yes. It does give the same. Oh, fiddlesticks, that's not what I wanted. There we go. Let's hide that guy. There we go. So yes, the length is the same as part A above. And the reason for that, and we'll get more into it, but it's called the commutative property of addition. It says that I can add in any order that I want and I will still get the same value. And so in this problem right here, by moving this one to the front, it doesn't change the value because of that.